Hello everyone, welcome to this video. My name is Amir Senahri. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to download Landcover products with 10-meter spatial resolution without any doing classification or clustering technique. It is ready to use product that is a very valuable product for your studies. And so to know how to do this process and how to get this data from the Earth Engine, go to the code editor environment in the Earth Engine platform. In the first step, we need to identify the region of the interest. As I mentioned earlier in the previous videos, there are lots of shapefiles available in the Google Earth Engine data catalog, enabling us to identify region of the interest by administrative borders or basin borders. Now, today I'm gonna select a province in my own country and download land cover maps with 10-meter spatial resolution for that region. It's very simple and also very easy to use. You can use this procedure for all around the world, and also the data and also everything in this tutorial not limited or restricted to a specific survey, to a specific region in the world. It is globally and publicly, freely accessible for all the users in all around the world. So, first of all, pin your study area through the drawing tools available here. I want to select Gilan province in the north of Iran. This region including variety of classes, urban area, croplands, forest, and also a water area, and on it goes. We have a diverse set of classes in this region, and also very interesting for me to select this region as a region of interest for this study. So here, throw a marker tool available here, pin your study area, and then throw the search places and dataset to type FAO administrative. As you can see, FAO administrative unit layers available for 2015 for country boundaries and first level administrative units. Actually, the first level administrative units refers to border of provinces, and also imported into the code, and you can see this as a table available here. If you need to get more description and information about this layer, click on the links available after importing, and you can get different kind of information about these products. So back to the code, and now make a new variable to filter the administrative layer of provinces using the location we have selected. So make a new variable, or ROI, or region of the interest, equals to get from table filter bound. We need to select the region that is selected by the marker filter bounds according to the geometry. So in the next level, I want to have focus on the region of the interest through the map.center object whenever code runs, and then through the map.add layer, I'm gonna see the shapefile of region of interest through the ROI, through the map.add layer. Save your code and run it again, or run the code, and as you can see, through that map center object, we have focused on the study area, and through the map.add layer, you can see the border of region of interest. So, and in the next level, I want to show you how we can call land cover products or ready to use land cover products with 10-meter spatial resolution into the Google Earth Engine platform. So make a new session in your code, and here is called land cover image. So through the search places and dataset, just type land cover, or you can type its name, the dynamic word. The dynamic word is one of the newest land cover products that provided land cover data according to the Sentinel data with 10-meter spatial resolution that is very valuable for the studies and available since 2015 according to the Sentinel temporal resolution and also the spatial resolution. Imported into the code, it is one of the rare land cover products available with a collection structure, meaning that for each date Sentinel is available, you will have Sentinel is available with cloud cover less than 35%. You will have access to the land cover map for that date, and also it's really important things. The other land cover products is available only for 1 year or only for 1 decade or only available annually in the best condition, in the best situation. But this product is available every 6 days, every month, whenever the cloud cover in your region is less than 35%, you will have access to the dynamic world land cover product that is really valuable things. So now I want to show you how you can download or get this data from the Earth Engine platform that is really valuable. So back to the programming steps and make a new variable. For example, I'm making a new variable as map equals to image collection. This image collection needed a filter date and filter bound because it has framing structure same as framing structure in the Sentinel-2 images. So that filter date, if you go to the data description, you will see that this image or these collections available since the 2015 and to now to the time that you are doing this process actually. Now, for example, I'm making this tutorial in 2024, meaning that this product is also available from 2015 to 2024. And then if you check on the bands, you can see that the variety of classes including in this land cover map, such as water, trees, grass, flooded vegetation, crops, and on it goes. And all the classes gather together into a single band as label. As you can see, there are different bands including one class separately, and also we have one separate band including all classes together. And in the label band, that is the target band in this tutorial, you can see the range of values we have, each one of them including a single or separate class, and with different color tables and so on. You can see that. So for each date we need to select the label image. So back to the code and throw the filter date. Imagine that for 1 year, for example 2023, I want to download I need to make a land cover map with 10-meter spatial resolution and download it from the Earth Engine and open it up into the desktop softwares I'm using. So dot filter date, and then through the dot filter bound, we can bounding our data to the region that I have defined through the administrative layer. So here, then through the print function, you can see how many elements available on their map image collection. Run the code. In the right panel, we have image collection, more than 500 elements available under dynamic world version number 1. As you can see, all of them are related to 2023, all of them sorted here from the earliest to the latest image for 2023 in different framing structure. And also you can see that the frame codes are different. Sometimes for one date we have multiple image because each frame covering a single area in my region of the interest. Because most of the time, because of the small size of Sentinel-2 images, a small size of Sentinel-2 frames, we can see that most of the time our region of the interest covering by multiple frames in single dates. That's why large number of images available for Sentinel for this region only for 1 year. And also here we have two problems. The first problem is that we need to find a way to mosaic these data for each date separately. That's the mosaicing problem in the first step. And another problem is that we need to make land cover maps, for example, for each month or each week, and also maybe we need to make land cover maps for the season, for each season, for each year, and but it is available, for example, according to the Sentinel, every 6 days or every 12 days. So these are two important problems that we need to resolve them. As you, if you followed my tutorials, my previous tutorials in my YouTube page, I showed you temporal collection function that is developed by the Google Earth Engine developers that is very, very helpful for the mosaicing and producing multi-temporal products. Using temporal collection function, we can convert this product to the monthly version or to the 6-month version or annual version or any temporal collection that you need, and also in the same time we can have access to a mosaic land cover map for our region of interest. That is really important things in such kind of tutorials. So now I'm gonna show you how to calculate temporal collection function that is necessary to know for the Earth Engine data analysis. And in the previous videos, I showed you how we can use temporal collection function for the time series analysis and temporal resampling regarding to the temperature, precipitation, and climatological data. But now in this tutorial, I'm going to show you how we can use that product for the, how we can use this function to make multi-temporal land cover maps. So now make a new section in the code, and it is temporal collection function. Temporal collection function. I'm trying to show you how we can make the land cover, how we can use Earth Engine with the simplest strategy that is possible. So temporal collection is a little complicated compared to other tutorials I have presented. So before going through the temporal collection function, I'm gonna show you the simplest approach to download land cover maps with 10-meter spatial resolution, and then I will go through the temporal collection function that is a little complicated and maybe you don't like it and you don't want to follow it. So the simplest approach, what it is? Simplest approach to have access land cover product for this region. The simplest approach in this way is that, for example, make a mode map, make a general map using mode statistical analysis or mode statistical function that produces a general map according to the frequency of each classes per pixels. So, for example, map to annual, I want to make an annual map. Already I have called all land cover maps available for 2003, and just using map.mode we can get the frequent classes in each pixel, and also using this map you will have access to the general classes repeated frequently during a year. So, and then through the map.add layer you can see the annual map that is created and clipped based on the region of the interest. That region of the interest here is ROI already selected, and then for the visualization purposes you can go to the dynamic, you can check the dynamic world, or even you can use your own visualization parameters. But just as you can see here, for each day 10 bands available here, but we need one band including all classes, that this is a label. And after getting mode, or before that, we need to select the band with the label name. So, and for the visualization purpose you can use some instructions available in the data page, go to the data page here, and also there is a sample code. There is a sample code or tutorial that you can use for your study. So as you can see, we have 9 classes from 0 to 8, and also with this palette that is available. So I'm gonna use this, copy and paste it into your code. That's the simplest approach to work with this product, and then I will show you how we can download or convert it to the multi-temporal Landcover product. So here, paste visualization palettes 1, 2, 3, 4, 5, 6, 7, 8, and 9. So as I mentioned earlier, we have 9 classes from 0 to 8, and then we need to have palette equals to visualize palettes or visualization palettes. So in the next step, we need a name for the layer setting. This is map for 2013, and then use the false to avoid automatic visualization that reduces the speed of processing effectively. So save your code and run it. After a few moments, you can see the map for 2013 that is created. We are waiting to see the Landcover map that is created. Here, there is a Landcover map. You can see here, as you can see, with variety of classes, the cropland, the forest, the rangeland, the urban area, and also the water content, the water class, all of them showed here. And now you can download this map from the Earth engine and use it in the desktop softwares such as ArcGIS Pro easily. It's very simple approach. Just use export that image to drive to download the final results. The final image we want to download is annual map that is clipped based on the region of the interest first, and the description or the name of the output. The name of the output will be annual map or anything you want. So, and the scale for the output should be originally based on spatial resolution to 10. But if it is a heavy if you have selected a very large area, maybe your output will be split into different mosaic. So to avoid such kind of problems for the export process, you can reduce the spatial resolution from 10 to 30 or even 100. So, and then max pixels, the maximum pixels that each image can include may include equals to 1E13, and also the region of the interest equals to ROI, and CRS, the spatial resolution, CRS, the coordinate system, equals to the original coordinate system that data have. Annual map, from annual map get info, from information of annual map get coordinate system information, and then save your code and run it. In the task, you can see the annual map is ready to run. Click on the run, and you need to and also it's saving the saving process started into the Google Drive, and after the tab color turned to the blue, meaning that the process of saving is completed, and then you can go to the Google Drive and download the final result. So that's the simplest approach to deal with this product, and also without any complexity. And if you want to get this product for a specific month or a specific day, or it is not available for a specific date because its temporal resolution is not daily. But if you want to get this product or get the Landcover product for a specific month, you can use the calendar range .filter earth engine .filter that calendar range, helping you through the 3 arguments available here to restricted your data for a specific month. For example, if you want to get for the summertime from month number 6 to month number 8, June, July, and August, you can set a start date to 6 and end date to 8, and the field should be months. And here finally you will have a map for the summer condition according to the summer condition, and you will get the frequent classes in the frequent classes according to the summertime. So that depends on you and depends on the purpose that you want to get and you want to download the Landcover maps for your region. So in the next step, now I'm gonna show you how we can download this product, how we can convert this product from 6 days or 12 days resolution, temporal resolution, to the monthly format. Imagine that I want to get for each month, I need to have one Landcover product to compare them and to see that how vegetation cover or how water cover changing in my study area. It's very simple and easy, but if you have a low experience in the Google Earth Engine, maybe this part of tutorial is a little complicated for you, and I am highly suggested to use the code that is attached below the video in my YouTube page that helping you to copy and paste some part of programming techniques that is really complicated, but start to try to practice programming technique to learn this coding techniques easily, because helping you in future to be able to write your own code and get your desired information without any referring to such kind of tutorials. So make a new function. Here we have a function, and function name is temporal collection. Temporal collection including multiple arguments. The first is collection of input images, and the second is the start date, and then count refers to the number of images we want to get in the output, and then the interval, the temporal difference between the first and second image, and finally we need a unit to set a unit of time for the temporal analysis. So in the first step, in the body, you need to make a list of sequence according to the number of images we expect to have at the end. Variable sequence equals to earthengine.list.sequence. So the arguments is start and end, starting from 0, and equals to earthengine.number, what we have for count. And as number is starting from 0, we need to subtract it from 1. So that's a list that helping us to actually this list is a frame or is a framework in which we can produce the output image in. And then we need to turn the start date from a string to the date format. So make a new variable origin date equals to earthengine.date, what we set for the start converted to date by this structure. Then the function returning the list of sequence in image collection format, and for each row in this list we need a function to calculate the time difference between output images. In this function, each row from the list considered as an I, and then in the body of new function we need to identify the start date and end date. start date and end date. These are two separate variables that can be calculated through the origin date and interval and also the unit. From origin date that advance, inside the advance the delta argument replaced by the interval Earth engine dot number interval dot the interval applied to each row dot multiply I based on the unit we set. So, and then the same code used in the next line for the end date with a little change. The change is Earth engine is here. Earth engine dot number I dot add 1 to select one unit after the start date. We need to consider the number of row as I and add it to one step after. So finally the final collection, the input collection return into the temporal date that or temporal span that identified through the start date and end date. And during the period from start date and end date, that could be 1 week, 1 month, 3 months, 6 months, or even 1 year, we want to get the frequent classes. The classes mostly occurred in each pixel through the dot mode as a statistical function. Dot mode is a statistical function that mostly used for the Landcover maps or binary images. So in the next step, we need to set the system time start and system time end through the start date and end date. That's set. The first property is system time start date dot millisecond converted to millisecond. It's very important because Earth engine originally uses a millisecond format for the reading the time information. So another property through the set system time end end date dot millisecond. So as you can see here, now we have a temporal collection that is ready to use. If writing such kind of function is difficult for you, no worries. The code sample attached in the video description in my YouTube page, you can pick it up there and copy and paste it into your own code. But I highly suggest you for future, if you want to learn Google Earth Engine and if you want to be a master into the Google Earth Engine, you need to learn writing such kind of codes in the Earth Engine easily and without any problem. So for the future, I highly recommend you to practice a lot to learn such kind of techniques. And it should be noted that this function not developed by mine, actually this is developed by the Google developers, and just I'm repeating this function in my tutorial, and just I am copy this in my tutorial and writing different its parts and explaining. And also it doesn't mean I have developed this function. No, it is already available and developed by the Google developers, and I have borrowed it and also using in this tutorial. So for the next step, I want to show you how we can use temporal collection to make the monthly map for 2023. So make a new variable, for example monthly equals to the mode statistical function helping us to mosaic and convert the temporal frequency from the 6 and 12 days to the monthly structure. We are doing mosaicing for our region, and also we are doing temporal resampling for the time span. So the function name is temporal collection. And as I mentioned, we have a couple of arguments available here that should be replaced with a value. The input collection equals to map, because map including all land cover maps for 2023, and a start equals to the start date, that should be same as what we have in the filter date, that is 2023 from the January, and the count means the number of outputs we expect to have. As 1 year as you know, each year including 12 months, and then and also as we want to get monthly data only for 1 year, the count or number of images expected will be 12 with 1 month interval. Here interval equals to 1 and unit should be months. So here through this function we are getting frequent classes in each month, and also we are doing mosaicing same time. So through the print you will see the monthly output. So here we have an image collection with 12 elements as we expected. But here we have a problem, because for each month we need to have only one band, but only for months number 5, 6, and 7 bands are available. So it shows that something is wrong in our code and we need to check it out and find the problem. As you remember, we used a calendar range only for the summertime. That's why our output only showing for June, July, and August. And if I remove the calendar range or set the calendar range from one or first month to the last month for each year and run the code again, we expect to have monthly mosaic for each month, monthly mosaic from January to the December, and for each month we have 10 bands. That is wrong, because we only need to select the band entitled as label. So to do this, throw .select from input collection we can select label band, and now for each month we have only one band, that is label. And then through the map.add layer you will see the monthly maps that is clipped based on the geometry, or sorry, that is clipped based on the ROI. Set the visualization, leave the visualization parameters empty, and the layer name monthly map, and then add false. So the monthly clip, the monthly image is an image collection. The monthly variable is an image collection, and to clip it, first we need to make a stack of monthly data through the .to bands and then clip it to avoid such kind of errors in the programming steps. So here we have a monthly map, and as you can see, from January to December the data is ready, and then click on apply. You can see the land cover for the January, the land cover that is produced for the January. Because of the cloud cover, sometimes maybe we missed some information for some dates. That is not really weird, and also because in the high latitude regions or mountainous regions in the cold season, mostly some regions or frames covered by the cloud, and also that's and also normally happens and causing miss some information for each month actually. So this is for February. You can see that in the mountainous region, mostly covered by the cloud. But if I select one image for July, for example, you can see we have a full land cover map with a less cloud cover. So, and if you want to download the final output, it's very easy to download it and also without any problem. But there are some solutions and methods helping us to set the name of dates for each band. For example, here when I print monthly.two bands, the name of bands is sorted according to the index name from 0 to 11. But now we can use a programming technique in the Earth engine to set the date as the name of each band. For example, when you read the name of each band, it is corresponding to the date of that band. And also it's very helpful for the time series interpretation in the ArcGIS Pro software in the desktop. But unfortunately, when we change the name of the labels, the label of each band or the name of each band, it is only readable in the ArcGIS Pro or in the Python programming language, and maybe it doesn't show then, and maybe if you are working with the QGIS, maybe the band name doesn't not shown there because of some restrictions in the QGIS for showing the label of each band. So now before getting export, I get the monthly data. So here I make a new monthly variable that is updated equals to get monthly data, and then throw the map, making a function each input element considered as an IMG, and from each input image I want to get date information. Make a new variable in the body part as the date equals to from each input image get date, and convert it to a string through the dot format. And then we want to have this date information with this format: year, month, and day. So finally, for each band that is returning, or each element that is returning, we need to have date with the we need to have that image with a new name, each img that is renamed to the date. So now if I print monthly updated, you will see again 12 elements, and each band showing the date of that image. And also it's very helpful for the band interpretation or data interpretation. When you import this band or this data into the desktop software, by the band name you can understand the date that image belong to. So, and then throw the export that image to drive. You can get the export. The image that we want to get export is the monthly data that is updated, monthly updated dot two bands. It is stacked, and then clip it based on the region of the interest or ROI, and then the description equals to, for example, the monthly layer, the monthly land cover, and scale equals to, for example, 30 meter, and max pixels, the maximum number of pixels we can have for each frame, 1E13, and then the region equals to ROI, the CRS or coordinate system equals to get monthly data, or we can use yes, monthly updated dot to bands dot get info. First, it should be converted from image collection to a stack through the dot bands, and then get its information and coordinate system. So it's enough, and now you can save the results or save the code and run it again. And in the task you can see that the annual map also saved completely, and no monthly Landcover is available here, and we can download it, we can save it into the Google Drive through the run button here. So now you need to wait until the monthly Landcover stored completely into the Google Drive, and then you can pick it up there and open it up into the software, softwares such as ArcGIS Pro, Python, a Python programming language, or even QGIS. And also, when you print the monthly updated with two bands structure in a stack format, in the right panel you can see that there is one stack image that's showing index of each image and year, month, and the day for each bands available. But as I mentioned, you can see the band names in the Python and also in the ArcGIS Pro, but unfortunately in the QGIS maybe you cannot see the band names, and also in ArcGIS, in QGIS maybe it shows the only band number 1, 2, and 3 and something like that. So this is the tutorial for today, and also I hope you like it as much as I do. And if you had any questions or problem regarding to the programming techniques, feel free to reach me out and put your comments in below the video,